There. All right, thanks, Cassie. Okay, so today we're going to discuss data and metadata, focusing on governance and access. And we'll discuss our experience working with the GBADS program, including PPS and data from the Ethiopian case study. And then outside the program, working with the OIE and FAO to establish useful data sharing. So much of the work done this summer was done by a big team of computer science and software engineering undergrads. And we were fortunate to have some really great and very skilled students working with us this summer who accomplished a lot. So this is a picture of most of them. And we also worked a good deal with PPS this summer, which was nice. So we've got a shot of that as well. So the overall theme for our talk today is research reproducibility as it pertains to data. So we've created the analogy, the road to reproducibility, where the stops along the way allow us to standardize, streamline, and communicate our data methods in research in a manner that is reproducible. Each of these aspects of reproducibility leads to the idea of a data utopia, where we can harmonize data from different sources and produce high-quality models and dashboards that enable informed and impactful decisions. The road to reproducibility not only aligns with the overall goals of GBADS, but also contributes to open science efforts. So today, as we cover the road to reproducibility, I'll describe a data utopia and what we mean by that. And then Cassie will discuss data and metadata quality and acquisition and ingestion of data. And then it'll come back to me to talk about the people and processes needed to make this a reality. So to kick off, we can look at a real world example of a data utopia and then the values and goals that we as a theme try to follow to achieve similar results. So to demonstrate how a high functioning data system can support substantial real world health and economic impact, we all as a team looked at the example of Taiwan's integrated databases and data systems that they were able to use during the early COVID response. So these systems are a large part of the reason that Taiwan was able to minimize both GDP loss and health impact. And while this isn't necessarily the same thing that we're doing with GBADS, it is a good example to show that it's actually possible to develop highly complex and functional systems that have a big impact. So as we kind of read about the system, there are several takeaways that we developed from the example that we can implement or keep in mind as we're developing the GBADS knowledge engine and throughout the wider program. So first was the ability to standardize and harmonize data from different sources. The Taiwanese system incorporated travel data, locally collected contact tracing, health insurance data. So it was able to do this from the village level all the way up to the national level, and the data could flow in both directions. And so we also need to ensure that we're able to incorporate different data from different systems and make it interoperable. Second, data from Taiwan's Central Epidemic Command Center was available and of high enough quality to quickly develop policies and actions. And that's our ultimate goal as well, right? As someone said yesterday, we want to make sure that what we do changes how people go about their decision making. So we want to make sure that we're sources of reliable and useful data with clear descriptions around any limitations that exist. And then third, in the Taiwanese system, there was high buy-in from the public, and a lot of this is due to transparency and also clear evaluation of user feedback. So within that system, they were able to crowdsource ideas and troubleshoot due to the real and meaningful channels for communication that were developed with the general public. And that's something that Theo and Ludo were just talking about. Really having those relationships leads to trust in data sharing, trust in the outcomes, trust in the integrity of the data, and trust in the decisions made on the backs of that data. So we really, again, want to ensure that we have trust and are transparent and communicative. And in our case, transparency also helps contribute to reproducible results. And then lastly, as mentioned yesterday, again, we want the system to be accessible to others. So in the Taiwanese example, they were able to have massive impact across sectors of health and the economy. And because their data was easy to work with to meet changing goals and situations. So we want to produce a system where people can follow their own ideas and do things that we hadn't even imagined. So after reflecting on that, as a team, we thought about our values and goals. First off, caring about sharing. We're big on sharing data and methodology openly. Early contact and clear communication are important as well. For a good working relationship, we need early and often communication, and too much is much better than too little, too late. especially because for the parts of the project that we're responsible for, we need a decent amount of lead time. There are some standardized guidelines that lots of people follow that we follow as well. FAIRS, CARE, and GATHER are the names of those core guidelines. And those are described in more detail in the data governance handbook, so I won't go too far into them, but they are principles for data and metadata, use and governance, and reporting, and you can read more about those in the data governance handbook if you like. We're also big on doing things once to reduce duplication of effort and just to get things done correctly the first time. And then again, the theme of this talk is reproducibility. So our overall team goal is to maximize the impact of GBADS. And we plan to do that by developing a framework for partners to identify and share data sources with the proper documentation, which can be difficult sometimes. We aim to streamline data acquisition and ingestion such that a small team can manage integration of a high volume of data. And we also want to make the methodology and data clear and accessible. So these values and goals kind of constitute the framework through which we conduct our work within the program and help keep us on track to trying to pursue that utopian GBADS output.
All right, and then the next thing on the road to reproducibility includes data preparation and quality assessments after data sources are identified. So here I'll outline our work on defining processes for data and metadata quality, including examples of each using the data sources we have identified in our work with PPS. So accessing data from different sources takes time, effort, and the right connections, as was said earlier today. And we have made connections with the OIE, FAOSTAT, and DADIS, and have been able to access data from each of these sources. And with the help of our co-op students this summer, a data deep dive exercise was performed to identify and document data sources of interest for PPS. These sources included the Ethiopia CSA, Eurostat, Stats Canada, OIE WAHIS, DADIS, and FAOSTAT. For each of the sources, when APIs were available, students documented how to use them to access data and metadata. When API documentation was poor or unavailable, they reverse engineered the APIs and provided documentation. And then for data that were only accessible through PDFs, web scraping programs were created to pull data off of PDFs into a more usable format, such as a CSV or Excel file. And then cloud stored databases were designed and created for all the data that had to be stored. And of course, once we have the data, we have to assess it for data quality. So data quality and preparation is incredibly important for reproducibility because it requires changes to the data through preparation and cleaning. And Forbes actually mentioned that data preparation, including assessing data quality and cleaning, accounts for about 80% of the work of data science. So it's a big part of it and takes a lot of time. And there are many different dimensions of data quality, which I'll go through. And documented data quality assessments inform data use, storage, and cleaning. So as Grace mentioned, we don't want you to reinvent the wheel, because if we want reproducible research, we check the quality, follow up with the data sources, and clean the data once, so then you don't have to. This also ensures that we are all using the same data for our models across the program, contributing to our overall theme of reproducibility and creating higher quality models and outputs. So first we look at the quality of a single data source, also known as the internal data quality. The dimensions that we focused on include accuracy, credibility, completeness, and consistency. The first is accuracy, or do the data show realistic values and data types? So for example, does the metadata reflect the content of the data? Are outliers present? If they are they minimal or realistic? And then notably, are there floating point numbers or decimals and animal population numbers? So I'd like to highlight this last point as we show you a real data source that we assess for quality. This is open data from DEFRA. Specifically, it provides cattle population numbers from the cattle tracing system for a number of categories for 2005 through 2020. However, it failed our accuracy test. 54% of the data were of incorrect data type, including decimals for cattle population data. So I don't know how there could be a fraction of a cow in any category. And obviously, this is extremely problematic. It's an indication of potential poor data practices, database issues, and poor quality data. This data is unusable in its current format, and then we have to create a report and make contact with the data contact point to gain clarification about the data. Next is credibility. Credibility is determined by the ability to find or access documentation about data collection and any other methods in the metadata or elsewhere. This includes a documented contact point for the data so that we can establish connection to ask questions or report errors to. And this is relevant also because it gives us an understanding of how the data can be used or combined. It is important for cataloging the data, so making this information known for data users. And again, that contact point, which takes time, trust, and you often need an existing network, as we heard this morning. And then completeness. So to understand the data, it's important to know when data is missing or wasn't collected, how this is represented, when the data was imputed and how, and when a zero actually means a zero as opposed to not collected. This informs the overall understanding of the data and what it represents, and tells us when data are missing or not collected and how this is represented. When we know it was likely difficult to collect data in a country due to natural disasters, famine, or historical events such as war, do the data reflect this? When there are disasters, are the data flagged accordingly, or is the previous year's numbers reported for the current year? Like we sometimes see in FAOSTAT Live Animals data set, when this is actually a true misrepresentation of the data. And consistency. So are there numeric or semantic contradictions? Are the units of measure consistent? Are the categories understandable? Do things add up like they're supposed to? So for example, we have here an example from some animal population numbers from OIE's internal databases. In FAOSTAT, sheep and goats are separate categories. And when combined to create the sheep/goats category, they add up to the sum of sheep and goats. In the OIE data shown here, sheep/goats is an independent field, except for in the last two countries where it is a sum. It appears that the OIE data is raw and prone to submitter interpretation and thus inconsistent. It also requires you to look at each of the countries and compare to understand where the data is inconsistent. For reproducible research, it's really important that our interpretation of the data is consistent across the entire program. So it's important to do this quality assessment for each data set before handing the data to other themes. And then we do external data quality assessments. So this looks at the agreeability between different sources. This means, do the same numbers from different data sources report the same number? And how do the categories between the same observations from different sources compare? So take, for instance, our external data quality assessment of the agreeability between OIE and FAOSTAT sheep and cattle population data. The image shows a selection of countries that show how unexpected the differences can be. Countries such as Australia and Canada have numbers that don't agree. And then the highlighted countries such as Pakistan, Rwanda, and Switzerland do. Obviously, this is quite unpredictable in terms of agreeability between sources. Okay, so now we'll go on to the acquisition and ingestion of data. We have been working on streamlining the ingestion of data using standard processes that all members of GBADS can use. So we worked with input from Gemma, James, Marie, and Will from Liverpool to create an online form where you can submit new data sources and supporting information. The output of the form is stored in the cloud, reviewed by the informatics team, and then cataloged. This allows us to organize this process and take us out of email and into a standardized system to manage our data. And of course, we can't anticipate all types, uses, outputs, and categorizations of data. So we'll soon be ready for feedback on the form. There's just a few things that we're still developing. And here's how the form looks so far. So you enter the form and you're first asked questions about data access and ownership, such as information about personal identifiable information and usage restrictions of the data you're submitting. This informs privacy restrictions of the data and where the data should be stored. So in a more secure place, for example. Not shown here are questions about the nature of the data itself, such as the data collection methods, data contact points, and categorizations. At the bottom of the form, you will be asked to provide the data either through a direct download or an API call. Amardeep, one of the software engineering students, is still developing the ability to define column headers and key terms in the data set. And then we ask you to outline any modifications made to the data, including the ability to upload supporting documentation about the data. Again, this is still under development, but we will soon be welcoming feedback from everyone, which we're excited about. And then another critical aspect to ensure reproducible research during data acquisition is provenance. So we really appreciate when you all send us data, it's great, but being as specific as possible is really important. I'm sure we've all been there. You see a really cool study with an interesting open data source, but you have to track through multiple publications or references to find it, wasting a lot of time. Even then, there may never be a specific enough reference to the data set for you to identify the right version or the columns used. To avoid this, please provide a unique and persistent identifier for the data, such as a DOI, citation, or dataset code. And some not so good examples include the data source homepage, such as the landing page, because then we have to look through, or just a journal article. So the context of the data is still useful, but it's secondary to providing unique and persistent identifiers. In addition, we should all be properly citing the data and any visualizations and shown in presentations and other communications. For example, here you can cite your visualizations this way, and please note the unique identifier to the exact data set, not just the landing page to FAUSTstat. And finally, for me at least, Grace still has stuff to say. Reproducible research also means reproducible code. So we've established a GBADS GitHub to share code with our theme and other members of GBADS. This allows us to develop tools to streamline calculations into the GBADS knowledge engine and have a unique and persistent identifier for all code. This promotes our reproducible research theme and contributes to open science efforts. So far, PPS, Liverpool, and Informatics has repositories, so please ask us to make your theme a repository and look at the best practices for code in the Data Governance Handbook.
Thanks, Cassie. So last but certainly not least on our road to data utopia are the people and processes. So I'll discuss our experience working with other themes so far and what we as a theme can offer to you. So working, Cassie. Thanks. So working across themes has obviously been critical for us as the informatics theme in development of most of our outputs and processes. So the input from the different themes and the knowledge they provide has been really great, and it's helped us build good habits for enhanced communication. So we've got quite a list of things that we've been able to accomplish with the PPS group, the Liverpool Analytics team. We've had some fun book clubs with the Ontology group and a lot of other groups that we've been working with. We've been able to develop some cool outputs. So as a theme, we can help others reclaim time and effort, as Cassie has mentioned, and increase consistency and reproducibility across the program. So again, I think Cassie's touched on this, but we'll go through it as well. When a new data source is identified, that data needs to be checked for errors or inconsistencies, and the associated documentation needs to be identified. And if there are issues, we can communicate with those data providers to solve them. And that includes things like the internal consistency issues Cassie highlighted. And we've spent a good deal of time and effort developing those working channels of communications with the right people at key data providing organizations. So once that data source is in good shape, then we need to harmonize it so that it uses the same terminology and categories as other data in the GBADS collection. And so we need everything in a format such that dates, places, currencies, those sorts of things are all compatible across the data collection. And then after that, often you need to transform the data in some way, for instance, from numbers of animals into biomass. And while there are many ways to do that, we want to be sure for each method, we're doing it in the same way across the program. So once all that's done, at that point, then we can provide data to other themes along with associated metadata, equations, and parameters that all match up with the rest of the data in the collection. And again, this contributes to reproducible research and ensures that we're all working from the same sources in the same manner, again, helping avoid duplication of effort across the wider program. And so after that, or one of the next milestones, I guess, that we're looking to achieve after the dashboard that we will present tomorrow is the launch of a data catalog, which will make it easy for everyone to access these data and associated metadata. So lastly, we'll end with some takeaways from working with PPS that helped us both consistently progress our work together. So first, and again, this was mentioned by Theo and Wudu as well, it's important to establish a common goal and be very clear on the components provided per group, who is doing what analysis and when. And so for us, working with PPS, that was, they're providing the biomass calculation and working through that. And we're working on the computing systems to develop the dashboard. Also, we maintain regular, but not necessarily super frequent meetings. So we always had that in the diary that there'd be a check-in point in however many weeks, so that, things didn't just fall off. And we also made sure to connect along several channels that people from each of our teams regularly use. And then finally, we communicated questions early and often to make sure that we fully understood each other's work and workflows. So together, these practices supported the people involved by putting in place processes that were already convenient to the styles of work that we have. So today we covered some of the data discovery, data ingestion, and also a little bit of data governance and data wrangling. And next time we'll talk about the dashboard that we've developed so far, which is a vehicle for communication and dissemination of the outputs of the models and analyses that everyone is working on. So you'll get kind of a full look at the range of data science that we're doing. And then I think we'd just like to end with a thank you to the students that were in the first slide. And we have all their names and PPS that we've worked with this summer that, again, they've done a mountain of work and it's been really great to have them.